Hello class, today we're going to be talking about sequences. Now, a sequence is just a list of numbers that follow some sort of pattern. I'm sure you can find a pattern to get from one number to the next in this list of terms. Each number on this list is called a term, and we can refer to them as A1 and A2, meaning term 1 and term 2, and term 3, and so on. Sometimes we refer to them as f of 1 and f of 2, meaning the first term and second term in function notation. Doesn't change anything. What would the next number be in this sequence if you can figure out what the rule is? Well, if you were paying attention, to get from this number to this number, we add 4. If this is the rule of this sequence, that should also work when going from 5 to 9, which appears to work. So since the rule is consistent for all of the numbers, there is a sequence that exists with these 3 numbers in them that follows the rule of adding 4. So the next number in the sequence should be 13 by adding 4. So if I asked you to find the 10th term of the sequence, you would just have to continue until you found the 10th term. Now, this is called a recursive sequence because the rule that we found is to start at a number, and then the rule, we're applying a rule, which is to add 4 to find the next number. So we're going to write that. This is what's called a recursive sequence. The problem with recursive sequences is if you want to find any particular term in the sequence, you have to go from the beginning to the end very slowly. There is also something called an explicit sequence, which we'll talk about next class, which you can use to find any term in a sequence really quickly. So the rule for this sequence is A1 is equal to 1, meaning the first term is equal to 1. And the rule is if I want to find the next term of the sequence, which is AN plus 1, meaning the term after the current term, so AN plus 1 will mean next term. I take the current term, which is AN, so AN means current term, and we're going to add 4. So this is the rule. So you need both of these things. You need a term, you need a starting term, and you need a rule in order to have a recursive sequence. In function notation, we would write f of 1 is equal to 1, meaning the first term is 1. And if I want to find f of n plus 1, which again just means the next term, I would take the current term, which is f of n, and add 4. So both of these things are just rules that tell you how to find the next term of a sequence. Now, occasionally on the regents, they will pop up and look a little bit different than these. So another way to write this sequence would be like this. So we could, by the way, the letter used doesn't really matter. So let's say I called it B just as an alternative method of writing this problem. B1 is equal to 1. And we could write the rule as Bn, meaning to find the current term, or whatever term I currently want, I can look at the previous term, which is Bn minus 1. So Bn minus 1 means previous term. And then I could add 4. So both of these things essentially mean the same thing. One says to find the next term, look at the current term and add 4. And one of them says to find the next term, one of them says to find the current term, look at the previous term and add 4. So it'll either say to find the current term, look at the previous term, or to find the next term, look at the current term. It means the same thing. All right, you can do that for function notation as well. We could have wrote f of 1 equals 1. And to find the current term of a sequence, I can look at the previous term and add 4. And you would just apply the rule to as many times as possible until you find the next term. So let's take a look at another couple of sequences. This next sequence here goes from 6 to negative 12 to 24. Well, to get to from 6 to negative 12, I can either subtract 18, but if I subtract 18 again, I won't get 24. So subtracting 18 is not the correct method in this particular sequence. It appears to be that I am doubling and negating at the same time. In other words, multiplying by negative 2. So the next term should be negative 48. So the rule for this sequence would be AN well, A1 is equal to 6 because we need our starting number. And AN is equal to 2 times AN minus 1. Alternatively, we could write AN plus 1 is equal to 2 times AN. Meaning if I want to find the current term, take the previous term and multiply by 2. Or if I want to find the next term, take the current term and multiply by 2. Oh, excuse me, negative 2. All right, let's take a look at the next sequence that's here. Our next sequence, we have to get from 5 to 14. Well, 5 to 14 is 9, so adding 9. But adding 9 won't get me to 41. Recursive sequence come up in problems like this where you have to use more than one rule to get to the next number. If there was just a simple rule like adding or subtracting, those are actually called arithmetic and geometric sequences, and they have shortcut rules, which we're going to talk about next class, called explicit rules. But this particular rule requires us to do 2 different steps. So the rule is multiply by 3, which is 15, and then subtract 1. So if we take 14 and multiply it by 3, we get 42. If we subtract 1, we get 41. If we multiply 41 by 3, we get 123, and if we subtract 1, we get 122. So we can find the next term by multiplying by 3, which would be 366, and subtract 1 is 365. So let's write a rule for that. This time let's write it in function notation. So f of 1, meaning the first term of this sequence, is equal to 5. And the rule for this sequence is if I want to find any particular term, let's say f of n, I'm going to take the previous term, and I'm going to multiply it by 3 and take away 1. I also could have written to find the next term, I'm going to take the current term, multiply it by 3, and take away 1. Let's take a look at another sequence here. We have 2, then 3, then 8, then 63. Now this seems like a difficult sequence, and this particular one is to square the number we're looking at and subtract 1. I only know because I made up all these sequences myself. So 2 squared is 4, minus 1 is 3, 3 squared is 9, minus 1 is 8, 8 squared is 64, minus 1 is 63. So that appears to be the rule. If I asked you to find the next term, you would take 63, square it, and subtract 1. And then whatever that result is, you would take, square it, and then subtract 1 to find the next term. So let's write this sequence. We'll call this particular sequence C. So C1 is going to be equal to 2. And the rule for our sequence, C of n, is going to be equal to the previous term, where we square that number, and then subtract 1. Alternatively, we could have said to find the next term in our sequence, we're going to take the current term, square it, and subtract 1. So again, you always have like 2 ways to write it, which is kind of problematic with these problems. Also, they always say when they start with the first term, but technically you can name this term 0 or term 5 or something, but it's kind of awkward to do that, so you might as well name it the first term. And let's take a look at this last sequence. This last sequence is a famous sequence. It's very important. This is called the Fibonacci sequence. The reason for it is this sequence actually gives you 2 terms. F1 is going to be equal to 1, and F2 is going to be equal to 1 as well. In order to find the third term, you actually need to know both of these terms. So this is a sequence with 2 given terms. The rule for this sequence is in order to find the next term, here let's say in order to find the next term, I need to look at the previous 2 terms in some way. So 1 and 1 somehow make 2. 1 and 2 somehow make 3. 2 and 3 somehow make 5. 3 and 5 somehow make 8. So the rule for this sequence is to find the next term, I have to take the previous term or the current term. In order to find the next term, I have to take the current term. So in order to find the 4th term, I need to look at the 3rd term and add it with the 2nd term, which is the previous term. And that's pretty much everything we need to discuss in reference to recursive sequences.